Hi, and welcome to this part 4 of our blueprint reading video. Now today I'm not going to make a case about what I'm going to be covering in today's video, because lately I've never gotten to the point that I want to get to by the end of the video. So we're just going to take it as it comes. So instead of doing a long intro, let's get right to one subject that I've been putting off for a few videos now, and that's dimensioning. Now, we've talked about tolerances, and that has something to do with dimensioning. But this time we're going to pay a little more attention to the lines themselves. So let's go take a look at some drawings and some examples of dimensioning.
Let's start by looking at our extension lines. Now, extension lines are just that. They're lines that extend the surfaces that we want to dimension so that we can affix our dimensions away from the part, making for a drawing that's less cluttered and a lot easier to read. The clamp on this project is quite small, but it does have a complex shape that requires a lot of dimensions. We can just imagine how cluttered it would be if we didn't use extension lines. As previously mentioned, extension lines are fine lines that don't attract attention, and they come close to but don't touch the contour lines. This helps to clarify the boundaries so that you don't confuse an extension line with a contour line. Sometimes extension lines aren't required. And sometimes a center line can be used as an extension line. Sometimes they seem to extend from nothing, as is the case with this extension line here, which is actually the offset extension of the project's horizontal plane. Sometimes they're curved, as is the case with this extension of the 1 1/8 of an inch arc. And this center spot here is actually another way of showing a type of extension line. And no, it's not some weird Canadian lingo thing. I would have normally called it a point, but in this case I called it a spot, mainly because of the letter G. I really don't know what the big fuss is all about for not being able to find the G-spot. I mean, there it is right there. I mean, come on. I can even put another arrow if it's not clear enough. I mean, it's right there. Extension lines on their own are kind of useless, but if we have dimensions and we have extension lines, well, we need to tie both together. And to do that, we use dimension lines. Dimension lines are discrete lines that shouldn't stand out from the rest of the drawing. They are often separated into two parts, and that's to make room for the dimension itself. And they end with an arrowhead. Removing the dimension lines from the drawing of a small part doesn't confuse things that much. That's mainly because the dimensions are quite close to the extension lines already. However, on a larger part or on a looser drawing, our dimension lines can really help to clear things up, as we can see with this hammer handle example. Now, you don't want to end up with a jumble of lines that just confuses the drawing even more. So your dimension lines should be stepped or positioned in a way to avoid overlapping lines. And whenever possible, your dimension lines should be cut and the dimensions affixed somewhere close to the midpoint of the line. But as we can see here, sometimes there just isn't enough room for symmetry. So if it has to be off center, well, that's okay. When we use a dimension line that only goes to one side, well, it's not called a dimension line, it's called a leader line. And again, they attach a dimension to an entity. But be careful. If the entity is represented by a line, well, the leader line ends with an arrowhead, as is the case here. But if the leader line points to a surface, well, then it ends with a point. And sometimes when dimensioning things such as arcs, well, the leader line's arrowhead can be positioned somewhere in the center of the line.
Another thing that we can find on a blueprint are section views. And although they are made to simplify the reading of a drawing, Oftentimes they confuse people because they're not quite sure what they're looking at. So let's take a look at some examples of sections.
Here is a really informal type of section. I wouldn't even call it a view. It's more just of a window to the inside of a part. I call them broken edge sections, and they are generally found on assembly drawings. Now, here's a section view on the end of a part that really is drawn like a full section, but it's a partial section because it just represents one end of the part, the rest of the part being constant and not requiring a section through it. Section lines are thick and bold, and the arrowheads on them indicate the direction of observation. In this example, the direction of the arrowheads on the section lines indicate to us that the viewer is positioned on this side of the part and is looking at the section in this direction. And here is our section view, section AA. Well, it's AA because our section line was identified as AA, not because it has a drinking problem. And this section is not a bottom section view. It's not a bottom view. It's not part of the projection. Now, section views can be part of the projection, but in this case, since it's not at the same scale and it doesn't align with the rest of the drawing, we'll just call it a detailed section view. One of the reasons for using section views is to eliminate clutter. Now, it's kind of like not seeing the forest because all the trees are in the way. Hidden lines and contour lines are important parts of a drawing, but sometimes there's just so many of them that they confuse things. And if we create a section, well, we eliminate a lot of them because obviously whatever is in front of the section isn't there anymore, and that's contour lines. And as a general rule, we do not show hidden lines that are behind a section view. In the case of this bench block project, well, we have a half section that's presented in the bottom view. It's called a half section because only half of the part has been sectioned. This gives us the best of both worlds because we can see the inside as well as the outside, all in the same view. And in this case, it makes that tapered cavity a lot more visible. And if we come back to the rest of the drawing, well, we notice something that's a little bizarre. There's no section line in the front view. And that's okay because if what we're looking at is clear and obvious, well, no section line is required. In this case, it's a half section. And half sections rarely require section lines because when we look, in this case at the bottom view, the direction of view is clear and what has been cut is also quite clear because we can see both sides. And we're going to end our foray into section views by looking at this offset section. This offset section is all in the same plane, but it is offset, as you can see by the red arrow, and it's offset so that we can see even more detail. Now, if you take a quick look over at the right side view, you'll see what a jumble of hidden lines and center lines we end up with because of the number of holes, counterbores, and threaded holes that are in the part. Now take a look at our bottom view, the one that has been sectioned, and you'll notice that it is a lot easier to understand. Now, this drawing really only required two views. It could have been a front and bottom or a front and right or left side views. But I added to the front and right views here this section bottom view just to make things quite clear. So sometimes we'll even add a view to a drawing when we're worried that the views that are there are a little difficult to visualize.
Another thing that we find on drawings are symbols, and there's all kinds of symbols. We can take as an example a surface finish symbol or a texture symbol. There's welding symbols and all kinds of symbols. So here's a few examples of some symbols that you can find on drawings.
Here's one that we find on a lot of my drawings, and it indicates that the surface that it touches needs to be machined. take note of its shape. It's a closed triangle with something that looks like a handle coming off of it. If there's a number placed just in front of the symbol, well, that indicates machining allowance. And in this case, we have 60 thousandths of an inch of machining allowance. What's machining allowance? Well, it's something we find mostly on castings, and it indicates the amount of material that was left on the rough part for machining. It doesn't mean that you should take 60 thousandths of an inch off. It means that you have 60 thousandths of an inch to play with. Now, here's a symbol that looks a lot like the other one. But notice in this case that the triangle isn't closed. If nothing else appears close to this mark, well, it indicates that the surface to be machined can be finished by any method. In other words, surface finish isn't important. However, if a number appears above the symbol, well, that's an indication of maximum roughness. And in this case, the 63 indicates that this surface cannot be rougher than 63 microinches. And in machine shop lingo, 63 microinches is described as being a good machine finish.
The next couple of points have to do with proportion. Now, that is not to be confused with scale. Drawings don't have to be to scale. If you look on all the drawings that I've been putting up here, well, you'll notice that in the headers it always says not to scale. And that's because they've been drawn with computers. And I don't know what size the person who's going to use the drawing is going to print it at. And obviously, if it's printed on a B size sheet of paper rather than on an A size, well, it's not going to be at the same scale. But that doesn't mean that a drawing can be out of proportion. Proportions are very important to understand what a part looks like. So if a part is twice as high as it is wide, well, it has to appear on the drawing as being twice as high as it is wide. In other words, if we want to produce a drawing of the Eiffel Tower, well, the Eiffel Tower better have the proper proportions so that we will recognize it easily. But that we don't have to draw it at a scale of 1 to 1, because that obviously would take an awful lot of paper. However, sometimes it does happen the drawings are out of proportions. And when they are, well, it has to be clearly indicated on the drawing. Now, what would justify an out of proportion drawing? Well, drawing revisions would, and extremely long parts. Let's say I wanted to draw a part that was terribly long compared to its height and its width. Well, obviously that would be hard to put on a piece of paper. So I might change proportions by introducing a break in the part. So let's take a look at revisions and breaks.
Here we have a pretty straightforward part. It's 2 inches long and everything in the drawing is proportionate. But let's say we wanted to change something, like the length of the part. If I change something on an existing print, well, I'll have to make a drawing revision note. Drawing revision notes exist to indicate to the reader that changes have been made and that one must discard all former or older copies of the print. The triangle above the dimension here indicates to us that this dimension was changed. The 1 refers us to a footnote that will indicate to us the date of the revision and the former dimension. But you may also have noticed that the dimension itself is underscored or underlined. And that's an indication that this drawing is out of scale. Sometimes when a part is revised, the drawing itself is corrected. But in this case, the drawing has not been changed. So it is out of proportion, and that dimension must be underlined.
Now, it could happen that you want to draw, or that somebody drew, a part that is quite long and thin. Let's say you want to draw a 12-foot long half-inch bar. I don't know why, but let's say you did. Well, it would be very awkward to get that shape onto a print. It would basically end up being a line. So if we want to get away from that problem, sometimes we can use break lines to shorten a part up. And here's some examples of break lines.
Here's an example of a type of break line that's used on most any shape, but that's generally reserved for short breaks. And here's a way of showing a short break on a cylindrical part. And here's the type of line that's generally used on long breaks.
Now, before we get to some practical exercises that you can take part in to help you with your blueprint reading, well, I think we should take a look at the order of this, or the sequence that you should use when reading a blueprint. One of the big problems with reading a blueprint is that we haven't been trained to read them like we've been trained to read books. When we read a book, we don't have much difficulty with the idea of not reading the conclusion before we read the introduction. There's an order to things, and we're used to that. However, when most people look at a technical drawing or a blueprint, they tend to look at it like they were looking at a work of art. And when we look at a work of art, well, our eyes are drawn through the work depending on how the artist composed the scene. Now, technical drawings aren't art. And they have to be well balanced. You don't want a drawing that's all scrunched up into one corner of your sheet, but they aren't art. They are a way of communicating. And if you want to read them properly, well, you have to adopt a sequence and stick to that sequence rigidly. The order that I like to follow is this one. I start by looking at the header of the drawing. I read it completely, 2 or 3 times, making sure that I don't miss any details. That's kind of like the introduction to the drawing. Then I look around for written notes or details around the drawing itself, because I know that if I don't look at them now, I probably won't pay much attention to them later. Because one thing that is sure for most people is once you start looking at the shape of the part, well, you're going to forget what's around it. Now, for some people, it's all about that base. But for technical people, anyways, shop people, it's more often than not all about that shape. And that is the problem. Once we get into the shape of the part, we do forget the rest. And I've seen many times students bringing me back a project that is properly completed, and very proudly and very happy to hand it in, just so that I can tell them that the part is very nice, but the plan called for 2 parts, not 1. And that obviously is information that isn't on the shape itself, but that's around the drawing, in this case in the header. It's important to develop an order and to stick with it. But another important part of blueprint reading, well, is visualizing the 3D shape from the views on the print. And there's no trick with that other than practice. And the best way to practice and learn it, well, is to do some sketches of parts that you have. Well, let me start by saying I'm very sorry for what's about to transpire here, because I'm not used to sketching on a whiteboard. I'm used to sketching on paper with a proper pencil, not with one of these erasable markers. But we're going to give it a go so we can see how to approach a sketch. And if you do enough sketching, practice regularly, well, you will get quite adept at reading blueprints and at visualizing parts. Now, just before we get to our sketch, let's take a few seconds just to look at drawing lines themselves. Now, there's a lot of techniques, but a few little tricks that you can use that'll really help is one, to draw a straight line freehand. If you want to draw a straight line freehand, you're going to have to practice, and you're going to have to stop looking at the tip of your pencil. When you draw the line, place the pencil where you want it to start, and look at where you want it to end, and go there without looking at your pencil. So, take a look and see. At my start point, my finish point, I place, and I go. Just that simple. For the circle, I'm going to use the same approach of avoiding looking at the tip of my pencil. I'm going to mark the start point, I'm going to mark the center point, I'm going to position myself, and then I'm going to draw my circle. Freehand, quickly, without looking at the tip of the pencil. It's the best way to do it. Now, for our sketch, we're going to go at it one step at a time. Instead of trying to draw it final right off the bat, we're going to draw, erase, and detail. And for that, we're going to first start by laying out our general shape of the part. And that means, what are its major dimensions in the three views? And we're going to do a front, right side, and bottom view in this case. Now, remember, I did excuse myself before I started this sketch. It is pretty rough, but it is complete, and all the lines are there, everything lines up, so my projection is correct. Now, if you practice this, if you sketch enough parts, even quickly, you will be able eventually to do it in the reverse order, and that is to look at a projection and imagine the part. Now, sketching is important for a machinist, not only because it helps you develop your capacity to visualize parts in 3 dimensions, but also because it permits you to communicate with other people, engineers, clients, and whatnot. But one thing's for sure, we don't sketch willy-nilly, and that's why I've been talking about sketching so much in this blueprint reading course. If you are going to sketch, well, you have to follow the same rules as you would if you were doing it in drafting. They're often simplified drawings and they're rough drawings, yes, but they still have to follow the same rules. Well, that concludes our 4th course, our blueprint reading course. That doesn't mean that we've seen everything that we need to see, because it is just an introductory course. But I think we have a good baggage of knowledge here that can really help us expand in the future. Now, things that will be covered elsewhere in little quickies are things like symbols on drawings. I'm going to have to do a little quickie eventually on surface finish and surface textures, and that will obviously include the symbols for those things. And we're going to be making a video eventually, or I'm going to be making a video eventually, about planning the sequence of operations for a project. And that has a lot to do with blueprint reading, but it really is a separate subject. So, until then, be safe, have fun, and happy machining.